Article 380 of the National Electrical Code addresses parallel conductors operating at over 600 volts. This section of the code provides specific guidelines and requirements that must be followed when installing parallel conductors in high-voltage systems. Understanding and adhering to these regulations is crucial for ensuring electrical safety and code compliance in such installations. Firstly, it is important to define what constitutes a parallel conductor system. In essence, it involves connecting two or more conductors electrically to form a single equivalent conductor. This is typically done to increase the current carrying capacity of the circuit beyond what a single conductor can handle. Parallel conductors are often employed in high current applications where the ampacity requirements exceed the capabilities of available single conductors. The NEC provides detailed criteria for the proper paralleling of conductors to ensure that the current is shared equally among the parallel conductors and that the system operates safely and reliably. Article 380 specifically focuses on systems operating above 600 volts. This voltage threshold marks a significant distinction in terms of electrical safety and the types of equipment and installation practices that are required. High-voltage systems present unique challenges and require more stringent safety measures to protect personnel and equipment from electrical hazards. Article 380 outlines the requirements for conductor selection, sizing, insulation, and termination when dealing with parallel conductors in high-voltage applications. It also addresses issues such as voltage drop, impedance balancing, and the coordination of overcurrent protection devices. One key aspect of Article 380 is the requirement for equal current sharing among parallel conductors. This means that each conductor in the parallel set must carry approximately the same amount of current. Unequal current sharing can lead to overheating of one or more conductors, which can ultimately result in insulation failure, conductor damage, or even a fire. To ensure equal current sharing, the NEC mandates that parallel conductors must have the same length, conductor material, cross-sectional area, and insulation type. These requirements help to minimize differences in impedance among the conductors, which could cause unequal current distribution. Another important consideration in Article 380 is the proper termination of parallel conductors. Terminations must be designed and installed in such a way as to ensure a reliable electrical connection and to minimize the risk of overheating or arcing. The NEC specifies the types of connectors and termination methods that are permitted for use with parallel conductors in high-voltage systems. These requirements help to ensure that the connections are capable of withstanding the stresses and temperatures associated with high current operation. Overcurrent protection is another critical aspect of Article 380. The NEC requires that parallel conductors be protected by overcurrent devices that are sized and coordinated to protect the conductors from overload in short-circuit conditions. The overcurrent devices must be capable of interrupting the fault current without causing damage to the conductors or other equipment. Article 380 also addresses the issue of voltage drop in parallel conductor systems. Voltage drop is the reduction in voltage that occurs along the length of a conductor due to its impedance. Excessive voltage drop can cause equipment to operate inefficiently or to fail altogether. The NEC provides guidelines for calculating voltage drop in parallel conductor systems and for selecting conductor sizes that will minimize voltage drop to acceptable levels. In addition to the specific requirements for parallel conductors, Article 380 also references other relevant sections of the NEC that may apply to high-voltage installations. These include articles dealing with grounding, bonding, overcurrent protection, and wiring methods. It is important to consult these other sections of the code to ensure that the entire installation complies with all applicable requirements. It is also essential to understand the definitions of key terms used in Article 380. These definitions provide a common understanding of the terms and concepts used throughout the article and help to ensure consistent application of the code requirements. Some of the key terms defined in Article 380 include parallel conductors, ampacity, overcurrent protection, and voltage drop. These definitions are found in Article 100 of the NEC. Furthermore, understanding the scope of Article 380 is vital. The scope defines the types of installations and equipment to which the article applies. Article 380 specifically applies to parallel conductors operating at over 600 volts. This means that the requirements of Article 380 only apply to installations that meet both of these criteria. For example, if you are installing parallel conductors in a 480 volt system, Article 380 would not apply. However, if you are installing parallel conductors in a 4160 volt system, Article 380 would apply. The NEC also addresses the issue of conductor ampacity. Ampacity is the maximum current that a conductor can carry continuously under specified conditions of use without exceeding its temperature rating. The ampacity of a conductor is determined by its size, insulation type, and the ambient temperature in which it is installed. The NEC provides ampacity tables that list the ampacities of various conductors under different conditions of use. When installing parallel conductors, it is important to ensure that the combined ampacity of the parallel conductors is sufficient to carry the load current. The NEC provides specific rules for calculating the ampacity of parallel conductors. The NEC also addresses the issue of conductor dirting. Conductor dirting is the reduction in ampacity that is required when conductors are installed in close proximity to each other or in environments with high ambient temperatures. The NEC provides dirting factors that must be applied to conductor ampacities under these conditions. When installing parallel conductors, it is important to take into account any applicable dirting factors to ensure that the conductors are adequately sized to carry the load current. In addition to the technical requirements of Article 380, it is also important to consider the practical aspects of installing parallel conductors in high voltage systems. These include the selection of appropriate equipment, the use of proper installation techniques, and the implementation of safety procedures to protect personnel from electrical hazards. High voltage installations require specialized equipment and tools that are designed to withstand the high voltages and currents involved. It is important to select equipment that is rated for the voltage and current levels of the system and that is listed or labeled by a recognized testing laboratory. Proper installation techniques are also essential for ensuring the safety and reliability of high voltage installations. These include the use of proper grounding and bonding techniques, the correct termination of conductors, and the proper installation of overcurrent protection devices. Safety procedures are also critical for protecting personnel from electrical hazards during the installation and maintenance of high-voltage systems. These procedures should include the use of personal protective equipment, such as insulated gloves and clothing, and the implementation of lockout-tagout procedures to prevent accidental energization of equipment. In summary, Article 380 of the National Electrical Code provides specific guidelines and requirements for installing parallel conductors in high-voltage systems. Understanding and adhering to these regulations is crucial for ensuring electrical safety and code compliance in such installations. By following the requirements of Article 380, you can help to protect personnel and equipment from electrical hazards and ensure the reliable operation of your high-voltage electrical system. It is essential to consult the latest edition of the NEC and to seek the advice of a qualified electrical professional when designing and installing parallel conductor systems in high-voltage applications. Understanding the specific requirements for conductor selection, sizing, insulation, and termination in Article 380 is crucial for safe and compliant installation. Remember to pay close attention to equal current sharing, proper termination methods, and overcurrent protection. Always refer to the latest edition of the National Electrical Code and consult with qualified professionals for specific guidance on your project. The information provided here is for educational purposes only and should not be considered a substitute for professional electrical advice. It is crucial to consult with a licensed electrician or qualified electrical engineer for any electrical work or installations to ensure compliance with all applicable codes and regulations and to ensure the safety of yourself and others. Proper planning and execution are paramount when working with high-voltage systems to mitigate potential risks and ensure a safe and reliable electrical infrastructure. Familiarize yourself with the relevant sections of the NEC and adhere to industry best practices for a successful and compliant installation.